a right-angled triangle prism with side of x centimeters, x centimeter, and h centimeter. The prism length is L centimeter, and the volume is 300 centimeter cube. A, show that the surface area A equals x squared plus 600 open bracket 2 plus root of 2 close bracket over x. B, show the value of x minimizes the surface area is cube root 600 plus 300 root 2. The A part says we should work out the surface area. So the prism here, I've made one myself. Okay, it's a terrible design, but so that's the prism. What I'm going to do is open that prism up and show the net diagram of the triangular prism. So it has a surface cross-sectional area here. It's a right-angle triangle, and it's extruded to a certain length, L, which is that one. And so what I'm going to do is open that. We need to work out the surface area. So the surface area will be that area plus that area plus that area plus that area plus this area. So here is the prism. After opening the prism, this is what we get. And we want to work out the surface area here. As you can see, we've got two of these right angle here, two of that right angle triangles. And then we've got 1, 2, 3 rectangles. And so that's what we're going to do to work out the surface area. For the surface area of this one here, it's going to be H times L. So that will be HL. And you can see the surface area for this one here will be XL. And the surface area for that will also be X times L. So that will be XL. But for this one, is going to be a half X times X, which is X squared. And this one here will be a half X squared. So that would be, well, 2½ X squared, which would just be X squared, because 2 over 2 we cancel each other. And then we've got 2XL, and then we've got HL. So that's the area we worked out from the net diagram. So the area of the right angle triangle prism will be A equals, well, we've got 2 times a half X squared plus 2 times XL. So that's XL at the bottom here and XL on the side, plus we've got the HL here, so that's HL. And if we simplify that, we get A equals 2 cancel 2, so that 2 cancel that 2, and then we get X squared plus 2XL plus HL. So the first thing we need to do is to eliminate H, because in the final answer we don't have H or L. So we need to eliminate H and L. So how can we eliminate H? We can see that's a right angle triangle. So if we apply Pythagoras theorem, we can see that that's a right angle triangle. So therefore, H squared must be equal to X squared plus X squared. So that's a right angle triangle, and that's the hypotenuse. That's the opposite or adjacent. So therefore, H squared will be equal to 2X squared, and H will be equal to, well, we need to square root both sides. So if we square root X squared, we get X. So we get X root of 2. If we square root 2, we just get root 2. Well, the next thing to do is to eliminate L. We have to look at the volume, and we've got the volume for the right angle triangle prism, and that's 300 centimeter cube. But the volume is going to be cross-sectional area, which is that area here. Or if I bring the prism in, so the volume will be the area here times the length of the prism. Because that's what you do. You just calculate that area here, and then you multiply by the whole length of the prism. So that's why it's called a prism. So that will be the area of that length, right angle triangle. The side here is a half x squared times L, and that equal to 300. If I multiply both sides by 2, then we get x squared L equals 600. If I divide both sides by x squared, L equals 600 over x squared. So we now know L, we know what H are in terms of x. So I'm going to place L and H back into the surface area equation. So therefore A, the surface area, will be equal to x squared plus 2x, but we know what L is, 600 over x squared, plus H and L. We know what H and L are. So that would be H is x root 2, L is 600 over x squared. So A equals x squared plus 2x, which is that 2x here, and then replacing L here, 600 over x squared plus H, which is x root 2, and then L, 600 over x squared. But there's a common factor here. X cancel, one x here, you got 1 there. Another x cancel, that x here, you got 1 there. So now A equals x squared plus 1200, that's 2 times 600, over x plus 600 root 2 over x. You can see they have the same denominator. So A equals x squared. You just add the numerator. 600 is a common factor in the numerator. So you do plus 600, open bracket, 2 plus root 2 over x. So we're meant to show that the surface area A equals x squared plus 600, open bracket, 2 plus root 2, close bracket, over x. And that's what we've got. So the next part of this question B, we need to show the value of x, which minimizes the surface area is that value. So basically we want to make sure that at the minimum surface area, the x value has to be that. And that if you plug that x value into here, we get the minimum surface area. In order to show whether something is maximum or minimum, you have to apply first derivative and second derivative. The first thing we have is that there's a relationship between surface area and x. So therefore, A is a function of x. In that case, we then say A equals x to the power of n. We can then apply the A, the x, the A dx, and that will be equal to n, x to the power n minus 1. And then we can also apply the second derivative, which is the 2a dx squared equals n into bracket n minus 1 x to the power n minus 2. So what that meant is we have to have these function in the form of a equals x to the power of n. We know from indices that 1 over x is equal to x to the power minus 1. 1 over x squared is equal to x to the power minus 2. You can see that 2 here is that 2 here. And the 1 here is the 1 there. So that's how we need to express that one. We need to change that from over x to x to the power minus 1. This is okay, but that needs to change. So then we can write a equals x squared plus 600 open bracket 2 plus root of 2 times x to the power minus 1. Now we can apply the derivative here. The reason why we're applying derivative is that when we differentiate and then we set the derivative to 0, that means that the a, the x, will be equal to 0 here. That's why it's horizontal. If you then differentiate again, you will get positive second derivative, or you might get negative second derivative. And that meant that the 2a, the x squared, is greater than 0. So that's positive, and that would give a minimum. So that would be a minimum. And if the 2a, the x squared, is less than 0, that's negative, then that would be a maximum. So you can see why you always have to find the ADX when the ADX equal to 0 in this case. Find the value of x, and that value of x is where the maximum or minimum is. So that's the value of x we're looking for. And that's why the reason why we differentiate second time is to justify whether it is a maximum or minimum. So if you find the second derivative and you put the value of x in it, if you get positive, that means it's a minimum. So that will be minimum. And if it's negative, you get maximum. So that's what we're trying to do here. The first derivative here will be the a, the x, and that would be, well, 2 times, you can see that's 2 times 1, so that would be 2x to the power of 1 minus 600 into bracket 2 plus root of 2 x to the power minus 2, because you just take minus 1 is minus 2. And if you then do the second derivative, which is the a, the x, the 2a, the x squared, right, differentiating that again, 2 times 1, that's 2 x to the power 0 minus 600. So minus 2 times minus 600 is plus 1,200, open bracket, 2 plus root of 2 x to the power minus 3. So those are the two derivatives that we need, the first derivative and the second derivative. With the first derivative, we need to set that to 0. So we have 2x minus 600 into bracket 2 plus root 2 over x squared. So I've converted that because that's 2 to the power minus 2. You know, 2 to the power minus 2 is 1 over x squared. So that's over x squared. And that equal to 0. So if I multiply that by x squared, multiply that by x squared, so therefore I get 2x cubed, because x squared times x times 2x is 2x cubed, minus 600 2 plus root of 2. And that equal to 0, because x squared times 0 is 0. And now what I need to do is move that to the right hand side. X cubed will be equal to, I'm going to divide 600 by 2. So x cubed is going to be 300 into bracket 2 plus root of 2. So that's what x cubed is. The 2a the x squared, and I know what that is, so we know that x to the power 0 equals 1. Anything to the power 0 is 1. Over, that's x cubed. So you can see that x cubed can go in there as x cubed. The 2a, the x squared, will become 2 plus, well, 1200 into bracket 2 plus root of 2 over the x cubed is 300 into bracket 2 plus root of 2. That cancels that, you get 4, and that cancels that. 2 plus 4 is 6. So the 2a, the x squared, equals 6. So that's positive. It's a minimum. X cubed equals 300 into bracket 2 plus root of 2. X cubed equals 600 plus 300 root 2. And if I cube root it, then the x value will be equal to cube root of 600 plus 300 root 2. That's the value of x that minimizes the surface area